The concept, the concept behind solving this question is the number of trailing zeros. This question can be solved by using the concept of trailing zeros because because all these number and the form of five powers of these numbers can be expressed in powers of 5 and 2. Now, um, x is equal to 6025 raised to power 56 multiplied by 128 raised to power 37. Number 625 is 5 raised to power 4 and 128 is 5 raised to 1 2 raised to power 7. Therefore, x equal to 5 raised to power 4 whole power 56 multiplied by 5 raised to power 7 whole power 31. Now property power gets multiplied. Therefore, 5 raised to power 24 multiplied by 2 raised to power 217. 217 because a raised to power b raised to power b whole power c is equal to a raised to power bc. Now, x clearly 217 powers of 5 can be combined with 217 powers of 2 to form 217 powers of 10, which is written here, and 7 powers of 5 are remaining. Now, the resulting number of x is equal to 5 raised to power 7 multiplied to 10 raised to power 217. X is equal to now now split 5 raised to power 7 into two constituent power, which is 5 raised to power 4 multiplied 5 raised to power 3 multiplied 10 raised to power 117, which is all common. Now 5 raised to power 4 is again 625 and 5 raised to power 3 is equal to 125. Now multiply 625 125 by following method. 625 divided by 8 multiplied by 1000, because 125 is equal to 1000 divided by 8. Now on dividing 625 by 8 we get 7 8 is 64. Then the remainder on dividing 625 by 8 the remainder remains 1. Then whenever on dividing by 8 the remainder is 1, put 1 2 5 after the decimal place, after the decimal, followed by multiply by 1000. Now the result is 78125 raised to power 217, which is written here. Now clearly x is equal to 78125 followed by 217 zeros. Now say try to calculate evaluation of y, we get 125 raised to power 85 and multiply 512 raised to power 30, which is because 125 is 5 raised to power 3 and 512 is 2 raised to power 9, which is on evaluating these we get 5 raised to power 255 and 2 raised to power 270. Again, 255 powers of 5 can be combined to, and the remaining in can are remain written here. So 255 powers of 5 combined with 255 powers of 2 to form 255 powers of 10. So then the result is y equal to 2 raised to power 15 multiplied 10 raised to power 255. Now 2 raised to power 15 can be solved by using splitting it into two parts, 2 raised to power 2 raised to power 3. When we know 2 raised to power 12 is equal to 4096 and 2 raised to power 3 is 8. Now on multiply 4096 multiply 8 multiply 255. We y equal to 768 multiply 2 raised to power 255. Now y, the value of y is 32768 followed by 255 zeros, which is already written here. Now the sum of digits of x is equal to 7 plus 8 plus 1 plus 2 plus 5, which is nothing but equal to 23. The sum of digits of y is equal to 3 plus 2 plus 7 plus 6 plus 8, which is equal to 26. Clearly, the sum of digits of x is less than sum of digits of y, so the outcome will be d1 is less than d2. This is the approach to solve question. The whole approach to solve the question is that you need to know the concept of number of trailing zeros, which are explained here, and this other thing can be asked in the question is number of trailing zeros in the expressions. Number of trailing zeros in x equal to 217 and number of zeros in y is 255. Thanks.